Okay, hi everyone. So make sure you have your notes out. Make sure you're actively taking notes. Um, just seeing this stuff isn't enough for your brain to acknowledge it. So, so please make sure you are taking notes. Okay. So today what we're doing is we're doing something called the slope of a line. Okay, slope, and that's the big deal. We're just going to refer this to as the slope. Hey, what's a slope? Is the slope increasing? Is the slope decreasing? What is the slope looking like? Okay, so the slope refers to, if I draw a line, and let's start at 1, and we'll draw the second dot. We'll draw a line to it. The slope is how much does something change? So this is another way of saying something as how does something change? And we always have to measure change of something with some type of metric, so some type of value and some type of comparison, like a change in your height. Some of you guys have grown, let's say, since we've been in quarantine, and you can say I grew 6 inches over the last 8 months, right? You have to compare it to something. I made $100 over the last week. That's a change. You can say I lost $400 though over the last week. So when we talk about slope, we're really talking about change, and change is always comparing one thing for another. It's always a ratio, we could say. This is a ratio, like in to out. So the ratio for us for this line, specifically here where we have x's and y's, it's going to be slope for us. It's going to be these two words, which it's actually 3, but it's going to be rise over run. We're going to talk about how much we're rising over how much we're running. Okay, so if we look at this graph here, is this graph increasing? Is it decreasing? Is it increasing? Or is it decreasing? And what is the slope? How much is it changing over the time from going left to right? We read in English from left to right here. So that's what we're going to see. Is this graph increasing or decreasing from left to right? So let's do the easy one. From point A to point B, is my graph increasing or decreasing? Ask yourself that. Am I making money, losing money? If this was a business and I gave you a chart of my sales, with A to B, does it look like I'm making money, I'm losing money? Am I gaining customers? Am I losing customers? And hopefully you guys can acknowledge B is higher than A, so this is increasing. So for this graph here, we are increasing. Now, how much are we increasing by? Thank you, we're making money, making some mucho dinero here. So what we're going to do is now we're going to look at the words rise and run. How much did I rise to get from point A to point B? And rise means it's a vertical distance. This is my rise, going up and down, and my run is going from left to right. Okay, my rise and my run. Rise is going up and down, straight up and down, like an elevator. And run is running left to right. Okay? So the rise is only one space. You all see that? That's one space. And on your paper, go ahead and make this a little bump. You're going to just crawl up by one space. That's one space. So my rise here is 1. That's it. And my run, that's start walking. So watch, I'm going to go up by 1, stop, and I'm going to cross over step 1, 2, 3 steps over. That's my rise over run. That's my slope. Now, a slope of 1 over 3 might not mean much to you right now, but I would say that's a small slope. Because if I write this as a decimal, isn't 0.33 not that big of a growth? Right? Imagine if I said, oh, my bank account grew by 0.33. You know what? That's actually really good for a bank account. But if this was an investment account, and maybe this was 33 years of my life, 0.33 isn't a big growth. So this is a slow growth. Now I want to compare this to a different slope here. Let's go ahead and redraw this again. Put a dot at 1. I'm going to actually do a different point here. And please notice A and B. Okay, I'm going to call this graph 1 and graph 2, just so that we can refer back to it. Let's write slope again. And again, the slope is what words do we use to describe slope? We use the words rise, over, run. Rise, over, run. Okay. So for this slope here, you can tell that the line is different, right? One is growing what we call faster than the other. So just like what what Jason said about making money, which graph made more money? Was it graph 1 or graph 2? And can you obviously tell that, right? I'm seeing some people say graph 2. You know what? And that's really obvious. And that's a cool thing about graphs. Without me telling you any numbers, you can automatically tell that in number 2, man, you're making a lot more money than I am. Imagine if you own store 1 and your friend owns store 2. Man, store 2's making money. Store 2's the Chick-fil-A of the fast food industry, while store 1's like the McDonald's. Okay, so let's calculate the slope of this one. What's the rise from point A to point B of this graph? Okay, what's the rise? We counted up, rise. How much space is up? I have to go space 1, 2, 3 spaces up, and my run is 1. So my rise is rise equals to 3, and my run equals to 1. And that's what we're going to write here, 3 over 1. If we reduce this, 3 over 1 is 3. Now compare the two. Which one has a stronger slope? Which one would grow faster? And that's how we use slope. A slope is a value, a numerical value that we can use to compare things. And the slope is a very easy calculation of just how much something is rising over how much something is running from left to right. It's always from left to right. Now, let's do one more slope here. Let's do step 3. And this is Mr. Ko's business. Mr. Ko's business is going to go from point A here to point B. So this one isn't nicely on the line, but let's go ahead and see if we can calculate what our slope is still going to be. Remember, the slope is just writing the two numbers separately. Tell me what the rise and tell me what the run is. And the rise can be negative. Okay, it can be negative. So let's go ahead and try this. If you guys haven't done so already, you guys can tell me what the slope is. Okay, so let's just count it. So the rise would be, to get from A to B, would we be going up or down? We're going down, right? We're going to be losing. So we're going to go negative 1 step, 2 steps, 3 steps. Oops, let me look a little better. 1, 2, 3, right? We're at 0 now. Then 4, 5. Slope is, the rise is negative 5. Rise is equal to negative 5. Now from this point here, we're like right here. How many steps over to get to B? We're going to take 1, 2, 3 steps. Positive 3 steps. And this slope is negative 5 over 3. If you want to reduce this, or if you want to write this as a decimal number, this is negative 1.66, rounding off. So if you hear of something with a negative slope, you know it's going to be decreasing. You're losing money. If we want to go into business, we're going to be talking about our increases and decreases, and that essentially is our change, our slope value. So how do we find slope? It's just simply counting the rise, which in this case was 1, 2, 3, 4, 5, and our run was 1, 2, 3. Okay, that's how we find slope from my graph. Easy peasy. Now, I want to show you something kind of interesting. Let's do one more example here. I'm going to put a dot over here at -2, -3. And then I'm going to put a dot, let's see. Right here. Okay. So this is point A and then point B. I'm going to draw a line through it. So we're going from point -2, 3 to point 1, 3. This is a -3, sorry. Okay. So we could do our classic way of climbing. Let's go ahead and just climb it. To get from -3 all the way to +3, we went 1, 2, 3, 4, 5, 6. So my slope is equal to rise over run. That's going to be 6. And my run will be counting steps 1, 2, 3. Okay, we can reduce that and we can say this is 2. Or 2 over 1, which will be helpful, which is 2. Okay. Now, this is saying a couple of things. First, it's that, hey, if I reduce the slope and it's 2 over 1, now here's something kind of cool. If I go up, count 1, 2, and I go over 1 step, that's another point on the line. If I go up, whoops, that one's a little off. 1, 2, and 1 over, look like there. And if we go up 2 again, 2 over 1, that's another point on the line. If I go up 2 over 1, 1, 2 over 1, what happens is when we reduce the slope, it still is every point on the line because the growth is the same thing. It's just 2. Whether it's from A to B or every step in between, it's still 2. Imagine if you got an allowance, okay? And you got an allowance every month, you get $100. Every month, you get $100. Okay. Or write this a different way, in the slopey way, $100 per month. Well, how much do you make every half a month? Wouldn't that mean you make $50 every half month? Are these two the same value at the end of the month? For the most part, yeah, right? How about, what if I say you make $25 every week? Because there's like 4 weeks in a month, right? Wouldn't this give you pretty much the same exact amount? If we say about there's 4 weeks in a month? What if I say you make $1,200 in a year? Is that the same thing as $100 per month? So this idea of slope is about how much something changes. Remember, we're always comparing one thing to another. And as we do these comparisons actually overlap. 6 over 3 is actually the same as 2 over 1. $1,200 per year is the same as $100 per month, which is the same as $50 every half a month, or $25 every week. Okay, so here is our next thing we want to talk about. What if you don't want to count spaces? We have a fast way of doing this also. Folks, can you tell me what is the distance from -3 to +3? How many spaces would I have to climb from -3 to +3? to get from -2, 3, -3 to 0.1, 3, what would the rise be? What would the rise be? And the rise is our y value. And our fast way to do this is just subtract them. 3 minus -3. Slope is rise over run. So the rise is subtract your y values. And then what's your run? You subtract your x values. And that gives us 6/3, which is the same answer we got here, which is 2. And this is what I want to focus the second half of our class on. The first half was just simply counting it from the graph. The second half is I don't want to graph it. I don't want to keep drawing that graph out. Instead, we can just do the numbers. So let me give you another example. If I give you the values 5, 4, and let's do 15, let's do 16. Okay, these are big numbers. I personally do not want to graph this out. No, this is too much. Too much work. So if I ask you guys for the slope, we're gonna simply subtract the numbers. And we have a formula for that. Slope is y2 minus y1 over x2 minus x1. What this refers to, y is going up and down, and x is left and right, which is our rise over run. Rise over run. So we're going to use this formula, and this formula will be, I'm telling you right now, you're going to be using it till calculus. So make sure you remember this right now. Slope, rise over run, is simply just subtracting your y's to figure out how far we went versus our y's, so our x's, which is our run. Rise over run. Okay, so that's label our value. Look at 5 and 4. X is our 5, y is our 4. We'll call it x1 and y1, referring to our first point. X and y, referring to our first point. How about the second one? We'll call it our second point. We'll call this x2, y2. So we can do this a couple of different ways. Okay, we can just follow the formula. Plug in. Slope is y2, which is 16, minus y1, which is 4. You can do that. Divided by our x2, which is 15, minus our x1, which is 5. And this gives us 12/10, which reduces to, divide both by 2, 6/5. This is our slope. Oops. And the slope doesn't have to be a whole number. Okay, now let me go ahead and show you the fast way some people rather do. So how many spaces does 4 take you to get to 16? How much did you rise? I rose from 4 to 16. I rose 12 spaces. How much did you run? From 5 to 15. You ran 10 spaces. That's the same thing that we did here. So you can do them both ways. You can either subtract it, which works, or you could go the other way by just counting from 5 to 15, that's my run, from 4 to 16, that's my rise, and it gives us our same answer. Let's go. That was a good guess though. Okay, we're gonna do this another time. I know I'm gonna show you how fast this is. You can do both ways. I recommend this way, knowing how to do this way first, and then we can do this way in our head. Okay, this is like mental, and this is writing it down. On the test, you will have to write it down, okay? So let's go ahead and do another problem. And let's pick -2, 3. And to our point, let's do 5, let's do 24. Now for sure, I don't want to graph this, right? I don't want to graph this. 24. But what is the slope? What is the change of what's going on here? I mean, if you really want to graph it, this is like -2, 3, and then 5, 24 is like way up here. That's our graph here. How many spaces up? That's our rise. How many spaces over? That's our run. But we have a formula. Slope is equal to y2 minus y1 over x2 minus x1. It's the 2's minusing the 1's. That's the whole idea. It's comparing 2's minus the 1's. You take your friends, you minus yours. You take your friends, you minus yours. And we'll see where we're at. So x1, y1, x2, y2. Why do we use those notations? Because if I called everyone x's and called everyone y's, if I said x, y, x, y, we do these notations because if I say, hey, everyone look at the x, you'll be like, half you guys will look at -2 and half you guys will look at 5. But if I say, everyone look at x1, everyone look at x1, we know where x1 is. Well, Mr. Crow, that's 5. Nope, that's x2, right? That's a different one. It's like a first name, last name, okay? I might have a lot of Johns, but the last names might not match. So let's go ahead and plug it in. Y2 was 24 minus y1, which is 3, over x2, which was 5, and y2, which was -2. Careful, I'm going to put in parentheses there in case I mess up on the negative. Because a negative become a positive. So it's going to be 21 over 7, which reduces to 3. Now, just to show this to you, that this made sense. If we were at -2, right, that's -2, and we go to 5, -2, all the way to 5, how many spaces would that have been? From -2 to 5. Imagine if you owed me -2, and all of a sudden at the end of the day, you had $5 in your wallet. How much did that change? You owed me -2, and now you have 5. You had $7 somehow. Someone gave you $7 to pay me back and for you to have an extra 5. And that's what happens when you do that negative sign. The negative become a positive, and the difference allows us to see we've actually gained 7 spaces. From 3 to 24, that's actually 21 spaces. That's it. Okay, so today's lesson is short because today is a short day, and that's it for today.